Hi, and welcome back. We are going to do a special lecture on section 9.4 so that we can talk about how to graph linear inequalities in two variables. So as far as today's lecture goes, it does seem like it's a little out of order. However, it directly aligns with what we have been doing as far as graphing linear equations. And in fact, the process is very similar. There's a slight difference, however, and we're going to go into that just now. If you look at the first example that we have, the first problem is 4x plus 3y is less than negative 12. Now, looking at this problem, it looks like a linear equation with two variables. The one small difference, which is actually a very large difference, is the sign itself. It is a less than sign, so it makes it an inequality. And so what we have to do that's a little bit different is we have to shade within our graph because that will mean there is a range of solutions possible. So let's jump right into it. Let's practice like we were graphing anyways. So I say graph, you say XY chart, go math. Here we are, we got our XY chart. My X and Y are both on the same side, so I'm gonna use 0 and 0 as my values, two different lines here. Get my intercept value, so 4 times 0 plus 3y is less than negative 12. That means 3y is less than negative 12, or y is less than negative 4. So negative 4 is actually the response I'm going to put in here. My next value, I have 4x plus 3 times 0 is less than negative 12. 4x is less than negative 12, or x is less than negative 3. So I'll use negative 3 here. So far, nothing out of the ordinary. Let's go ahead and plot. So at 0, negative 4, 0, negative 4, I have a point. So 0, negative 4, and 4, boom. And negative 3, 0, right there. Now, here's where it's a little bit different. This is the first stage where it's a little bit different. When I'm dealing with equations, my lines are solid. And that's because that is my solution set. It is equal to that solution, whatever my line happens to be. However, with inequalities, that's not necessarily the case. And there's an easy way to find out. If you think back to the few sections ago when we talked about inequalities for the first time, we actually introduced the greater than, less than signs and greater than or equal to signs. And we mentioned how some of those values are included or not included. Now, in this particular instance, we have a less than sign. And if you recall, just putting the notes over here for recall, greater than or less than signs are not included values. But greater than or equal to and less than or equal to are included values. And as you recall, just kind of expanding on those notes, with the not included values, you used open circles and parentheses. Well, now you're going to get to add to that. You're going to add dashed lines. Included values used solid circles, square brackets, and now you can also include solid lines. So going back, this is a less than sign, meaning it is not included within our solution set, which means our line here must be dashed. Just like so. Now, there is one more step still, and that is because that is not our solution, not our only solution anyways, it is a boundary. What we have to do is determine where the range of solutions are. And so there's an easy way to do this. There's a couple of workaround, like cheat ways, if you will, but one solid way that works every single time is choose a test point that is not on the line. Now, I highly suggest that you use the origin, or 0, 0, every single time, as long as your line does not go through the origin. If your line does go through the origin, you just have to pick a different point that's not on the line. But 0, 0 is very easy to calculate. So I'm going to use my test point as 0, 0. TP is my test point. Just to give identification, my test point is right here in relationship to my line. So it is not on the line at all. I take my equation and I plug in my values for my test point. And then I test to see if this is true, hence test point. So this comes out to 0 is less than negative 12. Ask yourself, is that true? Is 0 less than negative 12? And the answer is no. So what does that mean for me? 0, 0, my test point was right here. It proved to be false, meaning the other side of this line is true. So if this side was false, this side must be true. I shade on the side of truth because those are all part of my solution set. Okay, now let's try another one. It's a little bit of a process. It's the same process for graphing initially, getting your point values. It's a little bit different in the sense that your line has to be either solid or dashed based off of your symbol. But the most important part here, you must test with a test point to determine which side is part of the solution. Okay, very good. Let's try another one. So that way we can get this practice going. My next inequality, I'm going to step over just a little more. I have 2x minus 3y is greater than or equal to 4. We're doing the same thing. We're graphing, and then we're going to determine whether or not these the solution set for the problem. Okay, so graphing XY chart, here we are. I'm going to use 0 and 0 again. That's okay. As long as they work, you can use them. I get negative 3y is greater than or equal to 4. I have to divide by a negative, so remember that inequality sign must flip. So that is y is less than or equal to a negative 4/3. Again, for graphing fractions, all you have to do is click a point, and then you have to click that point that you just made, whatever it happened to be, and hit Edit Coordinates in MyMathLab. That will then allow you to type in exact values such as this fraction. Okay, let's try the next value and see what we get. So 2x minus 3 times 0 greater than or equal to 4. That's a 4. There you go. 4 there. Okay. 2x greater than or equal to 4. I really don't want to write a 4 right now. I don't know why. Okay. Divide by 2. X is greater than or equal to 2. We need to plot our values. So 0, negative 4/3. So 0, here's negative 1, here's negative 2. Negative 4/3 is a little bit closer to that negative 1. 2, 0. Now, is it solid or dashed? That's the question. Go back and check your sign. This is a greater than or equal to sign, hence the bar underneath, which means it is an included value. We can use a solid line here. And you're not done yet. You still have to have a test point. So a test point that is not on the line is 0, 0. I'm going to use it again. It's right there. So that means I have 2 times 0 minus 3 times 0 is greater than or equal to 4. This side works out to 0, greater than or equal to 4. That is a false statement. And so I am shading on the side that is true. So 0, 0 was false when I tested it, meaning this entire side is false. This side, therefore, is true. So shade on the side of truth. Okay, so that is all we have for the little mini lecture of section 9.4. It's really just to go over the concept. And as you're working through homework and quizzes, it will be on the test as well. This is just really a very simple process that builds on what you already know. Okay, thank you guys. I'll see you again in just another moment. Bye.